Bismillahirrahmanirrahim. So today we will discuss about introduction of data structure, what data structure is in actual, and anyone, guys, can you listen me properly? Please respond. Aisha Zubair.
Yes, sir.
If there will be any distortion in the voice or if there will be any problem or technical issue in the slides, you please have to raise your hand and let me know. Thank you.
Okay, sir.
So today we will discuss about introduction of data structure. What in actual data structure is. We will try to understand it and improve our data structure skills. Definition. First of all, we will discuss the definition to understand what the data structure is, as the word is explaining data and structure. What is data? Bulk amount of information, you can say, or anything you collect from others, or any data or any figures you can say is data. And what is the meaning of structure? So if we will understand this in this way, that we have to be very structured in this way to arrange in organizing the data, in arranging the data in a structured way. Like if you have a bookshelf and you have so many books, and you are just going to arrange the books alphabetically, like the book title starts from A is in shelf 1 and then in B in shelf 2 and so on. So you are just doing data structuring in actual. And similarly we will have the similar concepts in here in data structure. So data structure is a representation of logical relationship existing between individual elements of data. In other words, data structure is a way of organizing all data items that considers only not only the elements stored but also their relationship to each other. So how you are going to store the data and how this data has relationship with other data or with the queues. So we will discuss this in detail later. Introduction. Data structure affects the design of both structural and functional aspects of a program. If you have any program, computer program or anything, you should have to design it in so effective way that the data should be in a structured form, in an organized form. So what in actually program is equal to an algorithm and a data structure. So first you have to structure your all the information and data you have, then you have to design an algorithm. So what is an algorithm? Algorithm is the series of steps you perform to solve or to finish a particular function. Suppose if I will request a student to take a cup of tea for someone, and he or she don't know from where he or she can take that cup of tea, so he will design some steps in his or her mind that how he can get that. So this is in actual the algorithm, the simplest algorithm, and he or she will follow all the steps and will fulfill that requirement. So that's a program. First you have to structure the data, then you have to design an algorithm, and algorithm is the series of steps to understand or to solve that particular function. Data structure. Data are simply a value or set of values, not or, maybe there will be an or. Data are simply a value or set of values of different type, which is called data types, like string, integer, character types, etc. I hope in your previous classes you study the basic computer and what is integer, what is string and characters. So this is the basic concepts. Structure way of organizing information so that it is easier to use, easier to understand, like we just discussed about the example of books and bookshelf. So this is also a very simple way of organizing or structuring the data or books in the shelf. In simple words, it's a way organizing data in such a way so that data can be easier to use and understand. A data structure is a particular way of organizing data in a computer so that it can be used efficiently, a scheme for organizing a related piece of information. What is algorithm? An algorithm is a set of instructions written to carry out certain tasks, and the data structure is the way of organizing the data with their logical relationship retained. To develop a program of an algorithm, an appropriate data structure should select for that algorithm. Therefore, algorithms and its associated data structures form a program. So we already discussed about data structure and algorithm and how these two are connected with each other. Importance of algorithm is very much if you have a correct steps or series of steps to solve that problem and your data is in organized form. Simply, data should be in organized form to understand the relationship of data with one item to the other item, and the algorithms should apply to generate that program who can retrieve that data later. So why we study data structure, or what is the importance of data structure? Human requirements with computer are going to complex day by day. To solve the complex requirements in an efficient way, the study of data structure is needed. If nowadays, we have gigantic amount of data, large amount of data we have in, if you can say, a simple example, the data of Nadra, we have almost 22 crore people in our country. So you can say it's a large amount of data if you have data for one person, name, father name, address, and blood group, and education, married, unmarried, how many babies he or she has. So it's a large amount of data for one single person. So we have to structure that data. If we will not structure that data, we cannot use it efficiently. To decrease the complexity of data and to try to understand it in efficient way, we should have to understand it in a good way. Just give me a second. Sorry. So we were discussing about data structure and what is the importance of data structure. If we have large amount of data, we should have to organize it in an efficient way so we can use it for the benefit, provide faster solution of human requirements, and to provide efficient solution of complex programs to save time and space. So classification of data structure, there are so many not so many, some types of classification. So I try to cover all of these here. So here in this flow chart we can see data structure. There are two types. The first, primitive data structure, non-primitive data structure. In primitive data structure we have integer, characters, float, and pointers. And in non-primitive data structure we again have two classification, arrays and lists. In arrays we have single dimensional, two dimensional, multi-dimension. And in list we have linear and non-linear. In linear we have stakes, queues, and linked list. In non-linear we have trees and graphs. So we will try to understand in this lecture the basic of all these, and in detail we will study in our later lectures. Here we have another classification of data structure. Here we have two types like data structure, simple data structure, compound data structure. In simple data structure, we have integer, float, character, and pointer. Similarly, this one, primitive, also known as simple data structure. In compound, we have linear data structure and non-linear data structure. In linear data structure, like we discussed here, in linear data structure, we have stack, queue, and linked list, array, linked list, stack, and queue. And in non-linear, we have tree, graph, and files. So data structure are normally divided into two broad categories, like we see in the first flowchart. First one is the primitive data structure, and the second one is non-primitive data structure. In primitive data structure, we have integer, float, character, and pointers. And in non-primitive data structure, we have linear list and non-linear list. In linear list, we have array, queue, linked list, stack, and in non-linear, we have graph and trees. So what is primitive data structure? There are basic structures and directly operated upon by the machine instructions. In general, there are different representation on data computers, integers, floating point numbers, characters, constraints, string, constants, pointers fall in this category. So we were discussing about primitive data structure. Uh, it's the basic structure directly operated by the machine instruction, the instruction you give to your machine, that is in actual the computer, and it will totally apply on that. So it includes integer, floating point numbers, and character constraints, string constraints, and all these types of related information. So in non-primitive, it is much more, or you can say better, or more sophisticated data from primitive data, and these are derived from primitive data structures. The non-primitive data structures emphasize on structuring of groups of homogeneous and heterogeneous data items. The data have similar type of same type of data is in homogeneous, and different type of data in heterogeneous data items will also be included in this non-primitive data structure. List, stack, queues, trees, graphs are the examples of non-primitive data structure, and we will discuss all these in detail in this lecture, and then in advanced level in our later lectures. The design of an efficient data structure must take operations to be performed on the data structure. So with what common operations we can perform on a data? First one, create. We should have to create a data, or you can say create an array or create a list. First we have to create something, then we have to select some important information from that creation. After that we can update it, like if there will be new information or new data you have to incorporate that new data into your that creation. You can search, like if you create a data of, suppose in your area there is 100 people, 100 people is living, 100 houses are there. You just create a data, and create a you can say program for that, or arrange the data, and then you select that the person who have 4 children will be in specific domain. After that you just have I'm sorry. So we were discussing about non-primitive data structure, and we have to create that, select, update, and then we can search specifically. We have to sort it accordingly, or in a good manner way. We can merge the data, and in last we can also delete the data. What is the difference between primitive and non-primitive data structure? A primitive data structure is generally a basic structure that is usually built into the language, and it includes integer types and characters and floating. However, in non-primitive data structure, primitive data structure linked together in a meaningful way. So you can have linked list in, you can have trees and graphs in this non-primitive. That's the major difference. Simple data structure can be constructed with the help of primitive data structure. However, a primitive data structure used to represent the standard data types. Like we already discussed that what is the standard data types? We have integer, characters, floating, float number, floats, and numbers in computer languages as a standard data type. So we use these type data types to just construct a simple data structure. However, when we have to construct a compound data structure, we can have to take help from primitive data structure, and it will have specific functionality, and the functionality depends on the user, how user will design it. And it can be classified into linear and non-linear data structure. Then we have some other types in linear data structure, and others like graphs and trees in the remaining one. What is linear data structure? Linear data structure traverses the data elements sequentially with the specific sequence, or a logical sequence, or an understanding sequence, in which only one data element can directly be reached. For example, we have arrays and linked lists. However, in non-linear data structures, the data items we have has several other items that we should have to be specific for the reflecting, or to show the relationship between these specific data items. The data items are not arranged in sequential order. like trees and graphs. In linear data, like the word expressing that linear data structure has everything in a sequence. Like when you just go to a library, you can say if you want to hunt a book, title start from Q, you just go to that, or you W, or with any other alphabet, you just go to that specific rack and you can take that book out. It is that these books are sequentially arranged. So in linear data structure, we just arranged the data sequentially with the help of arrays and linked list. However, in non-linear data structure, we just have to explain the relationship among the data items, but there will be no sequential arrangements like graphs and trees. So operation we can perform on linear, non-linear data structure: add an element, delete an element, display the element, sort it accordingly what we need, and we can search the specific data we need there. So description of various data structures here. So we were discussing about arrays, linked list, takes, queues, trees, graphs. So now we jump on arrays. What is arrays? An array is defined as a set of finite number of homogeneous elements or same data items. If you have similar type of data, same data, and it's in finite number, not in infinite number, like 10, 15, 20, 100, 500, and data should be similar. So then you have to generate an array. It means an array can contain one type of data only, either all integers, all float numbers, or all characters. Like if you are working on the on the names of the students, then there will be only characters, because we don't have one or two or numbers in the names, like Ali, Ali, like Ahmed, Ahmed. So all these are characters. So similar type of data we can generate an array. However, if we are just discussing about the final exam numbers of students, then we will jump on numbers like 10, 15, 10, 15, 9, 4, depends. So here is we have here we have an example of integer, oh sorry, arrays. Array is commonly used in computer programming to mean a contiguous block of memory location. First we have to you can say arrange a memory location, or give a call to a memory location where each memory location stores one fixed length data item. For example, array of integers, here we just denote it like int mean integer type, a mean array, and this scale bracket in 10 shows that there will be 10 specific numbers can save in that specific array. Array of character like char, like character. B, it is an other array, and bracket with 10 shows that this array can also save 10 different numbers. Here we have the example like array of integers like this one, from 0 to 9, and we have 10 different numbers here. Similarly, in we have another one from 0 to 9 in characters, and we can save 10 different numbers in this one. That's the concept of array. Simply declaration of array is as follows. Simple declaration, how you can call an array, how you can create an array. First of all, you have to write it int mean integer type. You can write here char character if you want to add the character, and depends on the you can say scheme what you want to generate with array. And this one will show the location or the numbers you can save, how many you can save, where integer specifies the data type or type of elements array stores. ARR is the name of array, and the number specified in the scale bracket is the number of elements an array can store. This is also called sized or length of the array that we already discussed. Following are some of the concepts to be remembered about arrays. So you should know these concepts so you can understand it more efficient way. Like in the first example, we can see here that it starts from 0 and ends with 9. However, we have 10 in number. Same concept now we are going to study here. The individual element of an array can be assessed by specific name of the array, following by index or subscript inside square brackets. The first element of the array has index 0, like we show in the previous, that it starts with 0 and it will end on 9. So first element will be 0 and the last element will be 9, but in actual we have 10 different 10 characters or 10 different integers we can save in that location. The elements of array will always be stored in consecutive memory location continuously. 1, 2, 3, 4, like a box. The number of elements that can be stored in an array, that is a size of array or its length, is given by the following equation: upper bound minus lower bound plus 1. Like what we have in the upper bound, 0 minus lower bound, and then we 0 minus 9, upper bound is 9, lower bound is 0, 9 minus 0, 9 plus 1, 10. So in actual we can store 10 different numbers in that specific array. What we have, like here we can see it here, we have this upper bound is 9, and this one is lower bound is 0. 9 minus 0, we have 9 again in result, then we have to plus 1 according to the question, and we have in total 9 minus 0 plus 1, we have 10 in numbers. So if we will count here, 1 2 3 4 5 6 7 8 9 10, we have 10 in 10 here. For the above array, it would be like low. It explains here. 9 minus 0 plus 1 is equal to 10, where 0 is the lower bound of array and 9 is the upper bound of the array. Array can always be read or written through loop. I hope you guys studied about for loop, while loop in your basic computer science classes. If we read one dimensional array, it requires one loop for reading and other for writing the array. Here is an example. We have reading an array. This is the for loop. If you just guys remember the writing way, or you can schema of the writing for loop, like for I is the number, is equal to 0, I should smaller than and equal to 9. So this is the lower bound, this is the upper bound, and I plus plus mean in every time you have to plus 1 1 1 1 1. So this one is the for loop, and this is the dimension of, you can say, and array, and I is that I that starts from 0 and will ends with 9, and every time you have to plus 1. Now how you can read it? However, when you are going to write it similarly, for loop, I is equal to 0, lower bound starts with 0, and I should less than and equal to 9. It means that I can only go with 9. 1 2 3 4 5 6 7 8 9, and every time you have to plus 1. If we are reading or writing two-dimensional array, it would require two loops. In one-dimensional array, we have only one loop, that is a for loop. And you can say, you can understand, or we already have discussed it, that how one-dimensional array works with 0 1 2 3 4. And if there will be two-dimensional array, then there will be two loops. And similarly, the array of an n dimension would require n loops. If you have three-dimensional, then you have to generate three loops, 4 5, and so on. Some common operations performed on arrays are creation of an array and traversing of an array. Insertion of new elements, deletion of required element, modification of elements, and merging of arrays are the basic operations you can perform on array. So what is the disadvantages of array? We must know in advance how many elements are to be stored in the array. If you don't know about that, you cannot generate an array. Suppose in 10, we generate an array of 10 numbers, because we know that in our class we have 20 students, we can generate an array. If we don't know about the numbers, so we cannot generate an array. Suppose we generate an array of 50 numbers. However, total applicants are 90. So what will happen? So that's the one disadvantage of array. Array is a static structure. It means that array is of fixed size. The memory which is allocated to array cannot be increased or decreased. We already discussed this. Array is a fixed size. If we allocate more memory than requirement, then the memory space will be wasted. Because if we just take an example of, we make an array of 50 students, however we have 90 candidates, and suppose if we will jump on 500 number of arrays, and we consider that we will have 500 numbers in array, but however we have only 100 candidates, so we wasted the memory of 400 numbers. The elements of array are stored in consecutive memory locations, so insertion and deletions are very difficult and time consuming. So here we have a representation of a linear array in memory. The element of linear array are stored in consecutive memory location. It's shown below like this. Here we have a linear array A. These points are 1 2 3 4, known as index. These are the values we write here, like 10. Let's suppose we can say the pocket money of a student. Student 1 pocket money is 10, other 200, 100, 3, third student 20, fourth student 500, fifth student 600, and so on. So base address we have 1000, 1002. This is known as address in bytes. So this is the way we represent the linear array. So after array, we discussed about lists. What is lists? We have a list like linear linked list can be defined as a collection of variable number of data items. Lists are the most commonly and non-primitive data structures. An element of list must contain at least two fields, one for storing data or information and other for storing addresses of next element. You always have to generate two or contain two fields. In first one you will store the data you have, like you have your number 100, and then you also have to give another field where you store the address of that, the address of the next element you have to add. As you know, for storing address we have a special data structure of list. The address must be pointed type. So here we have an example of linear linked list. Technically, each such element is referred to as a node. Therefore, a list can be defined as a collection of nodes as shown below. Head, here we have an head, then we have this type of two boxes. First one is information field. As we discussed, we need two fields. In first need we have a data, and the other field we have a pointer field, that this data will move towards this one and this data will move towards this one. However, in the third box with the two fields, first have the information CCC. However, the other one we have a cross, that we are not going another address of another information. We a next information or element we want to add. So that is the representation of linear linked list, in which here we have, you can say, address of AAA has the second field and address of BBB, and BBB has the address of next element CCC. However, we don't need the new address, so we don't fill this address. So there are different types of lists. There's single linked list, doubly linked list, single circular linked list, and doubly circular linked list. So linked list could alternatively used to store items. In linked list, space to store item is created as is needed and destroyed when no space on longer. So we were discussing about the list. In linked list, space to store items is created as is needed and destroyed when space no longer required to store items. Hence, linked list is a dynamic data structure, space acquired only when need. So here we have an example like it's a linked list. We have 17 number, then we have address of 23. In 23 we have an address of 55. In 55 we have an address of 72, and so on. Here we just make it open and it can be move. However, like in previous example, if there will be a cross, then it will be stop, it will stop here. So this is the dynamic data structure that can move into any other and any other way, and the space, we just need a space to just elongate our array, oh sorry, list. So after list we have a is a data structure in which items can be inserted only from one end and get items back from the same end. Like here we have an example like this one. If you just want to add the beads here, so this is the only one way to add the bead, and the same way you have to extract the bead from there. The last item inserted into the stack should be the first item to be out in the stack. If suppose if you have a container and you are making a breakfast for yourself and you are just making the slice, so you are putting the slice on one on another, so the slice you make it on the last will be the slice you will take first out. So it is also known as last in first out, LIFO. So we have running of time from the lecture, as Zoom has limitation of only 40 minutes recording for the lecture. So I think we will stop our lecture on stake and will continue later the same lecture in our next class. So we are just going to summarize the stake here. A stake is also an ordered collection of elements like arrays, but it has a special feature that deletion and insertion of elements can be done only from one end, called the top of the stake. And similarly, due to this property, you can only take the first item out and known as LIFO, LIFO, list last in first out. And with the top of the from the top we can enter, or for the top we can take any data out. So that is the concept of stake. If it could be true of just like a stack of plates placed on a table in a party. A guest always takes off a fresh plate from the top, and the new plates are placed on the stake at the top. Similarly, we discuss about the example of a bread slices. It is a non-primitive data structure. When an element is inserted into stake or removed from the stake, its base remains fixed where the top of the stake changes. So here we have a graphical representation of a stake, that how the element inserts and out. Insertion of element into the stake is known as push, and the deletion of the first element out from the same side is known as pop. The below show figure how the operations takes place on the stakes like push and pop. This is the stake we have, like this is a container and we have a plates here or a plate data here. So first, if we want to add an element, we will use the word push to add the data, and if we want to take the data out, that's the term known as pop. So the stake can be implemented into two ways: using arrays, that is known as static implementation of the stake, and using pointer, that will be the dynamic implementation of the stake. So what is the application of stakes? It is used to reverse a word. You push a given word to stake letter by letter and then pop letter from the stake. Undo mechanism in text editor is the example of a stake. Like when you just use the control Z, control plus Z, and you will have the you can say undo of the last do what you for your text. Backtracking, this is a process when you need to access the most recent data elements in a series of elements. Excuse me. Once you reach a dead end, you must backtrack. Language processing, compiler syntax check for matching braces in implemented by using stake. Conversion of dynamic decimal number to binary to solve Tower of Hanai, and conversion of infix expression into prefix and postfix. And then you have in last the application as a quick sort. So we have application of stakes here, and we are going to summarize our lecture here, how, because we have less number of time, and then we will continue later in this lecture. So we discussed what is data structure and what is data, how we structure the data, organizing of data. Algorithm is the series of steps we perform to solve a specific function. Then we have a classification of data in primitive and non-primitive form. In primitive and non-primitive, we again have compound and compound and simple data. Then we have linear arrays. We have stakes, queues, graphs, trees, and we discussed about the arrays. What is the lower limit of an array and what is the upper limit of an array? How we can generate array, of which functions we can perform an array? What is the disadvantages of array? What is stakes, how we push the data in stake, and how we pop the data in stake. So all these we summarize in this lecture. If anyone has any question, please raise your hand. Okay, thank you so much everyone for joining, and we will continue our lecture from this point later in next class. Thank you so much.